In this segment of evaluating labor market models, let's begin to take a look at the two equations, labor supply and labor demand, as a system of two equations that are helping us understand this market, but wherein now we can think about solving for market clearing levels or equilibrium levels. So if we have the labor supply and labor demand curves as we have here, we can think about these in our basic model, of course. We have labor supply, labor demand, and we then have some W star and some L star, which we know are simply the market clearing levels of labor and wage in this model. We've seen this a number of times now. But let's think about how these equations help us understand what's taking place here. Well, let's think about labor supply to begin with. We've already talked about how we can think of equilibrium in this, so let's find we've already talked about how we can think of intercept values with these two equations. So let's go ahead and provide the intercept values by working that through again very quickly. So we will think about labor supply. So when labor supply equals 0, we know that 0 equals negative 120 plus 12W, or 12W equals 120, or W equals 10. Or when wage is equal to 0 in this labor supply relation, then we have labor supply equals negative 120 plus 12 times 0, which of course is simply negative 120. Let's do the same exact thing for labor demand. So when labor demand is equal to 0, then what we have is 0 is equal to 60 minus 3W, or 3W is equal to 60, or W is equal to 20. But when wage is equal to 0 in the labor demand relation, then we have labor demand is equal to 60 minus 3W, or 3 times 0, which means it's simply equal to 60. And recall that we can do this because when we are on any point on the W or Y axis, the value of labor is 0. Similarly, any point on the labor or x-axis, the value of W is 0. So we've been able now to think about what our values are here. So we have W at 20 for labor demand, and we have labor at 60. Let's rethink that a little bit. 60 on the L-axis. And then we have wage at 10 for labor supply. But we have, when wage is 0, labor supply is negative 120, which would suggest that as the labor supply curve continues to come this direction towards the x-axis, that it's going to cross it at a negative value. So remember, we've talked about this. We can think of this in negative space as well. Well, that's fine. We've got some points here, and we think we know something of what they might mean. At a wage of 20, this firms demand 0 workers. But at a wage of 0, firms are only going to demand 60 workers, no more. At a wage of 10, workers will not supply their labor. It must be a wage above 10, and so we think about 10 as the reservation wage. But now how do we identify W star and L star? Well, let's think about this. We know that equilibrium or market clearing levels are simply the point at which labor supply and labor demand, are equal at a given wage. Well, if that's the case, then labor supply and labor demand are the same value here at that wage. So we can think about this then as a system of two equations with what seems to have 1, 2, 3 unknowns, but in fact only has one unknown in L because L is the same thing at this point, has the same value at this point, and W, the second equation. So a series of two equations and two unknowns. And we know algebraically when we have a system of two equations and two unknowns that we can solve for both of those unknowns. So let's think about this in terms of setting the labor supply and labor demand equations equal to each other and solving for W star and L star in turn. So really we're saying if LS is equal to LD, which LS is equal to LD at the market clearing or equilibrium point. So when that's the case, we have negative 120 plus 12W being equal to 60 minus 3W. Or if we rearrange this algebraically, we have 15W being equal to then 180, or we have W being equal to 12, which really is W star. So 12 equals W star. Well, now that we have that value, we have to think, how do we find L star? Well, we're not going to set the equation equal to each other again, not going to set the two equations equal to each other again. If we took this new W star value of 12 and plugged it into L, or labor supply, it would give us the labor supply value. If we then go ahead and take W star and plug it into labor demand, it'll give us the new labor demand value. But in this case, because labor demand and labor supply are the same value at W star, it doesn't matter which one we plug it into. It'll give us the same value. So I always default by putting into the one that seems simplest to me, and I'll use labor demand. So labor demand, which really is L star here, since that's what I'm solving for, L star is going to be equal to 60 minus 3 times 12. Well, 3 times 12 is 36, so I believe that would tell me that L star is equal to 24. So we've been able to take a series of two equations, or a system of two equations, with what seemed like three unknowns perhaps, and we've been able to recognize it's actually only two unknowns. We've been able to solve for those two unknowns and find the market clearing level of wage, market clearing level of labor. We've also found our intercept values, which we've seen previously in this series, and now we've gotten equilibrium for this market.